Now, if you do have a mixture and you want to separate it because you have two substances mixed together, one of the common things that people do in chemistry, one of the big things is taking something that's a mixture and separating it. In fact, most things in nature are mixtures. You dig up some iron ore out of the ground, you want to separate it into the iron ore and get all the other crap out of there. Basically, a lot of chemistry is just separating mixtures, trying to get them into pure substances, and then you might be able to actually separate those compounds into elements. But separate mixtures to get pure substances. Now, to do this, you have to exploit their properties. I said that wrong. Ready? You have to exploit their properties. So let's say you have two or more substances. They have different properties. Okay? Pick a property that's not the same between them. And if you have something that's not the same between them, you can use it to separate them. For example, magnetism. Okay, if one of them is magnetic and the other is not, you can use a magnet to actually pull the magnetic one out, leaving the non-magnetic one behind. Other examples, dissolving. Maybe one dissolves and the other doesn't. Evaporates. Maybe one evaporates and the other doesn't. Okay, so lots of properties to choose from here, but you exploit them. You pick one that they do not have in common, use it to separate them. So here's some examples. Size. You can separate them by size if they're different sizes. You can use a strainer. It's got holes in it. Shake them, and then small things will go through the holes, large things will stay put. Okay, this is actually how they separate coins a lot of the time at banks and in different machines. So drop them in there, they're all different sizes. Roll down, and it'll actually separate them into different size channels. Okay, you can separate them by density. They have different densities, that's one of their properties. Right? So if one's less dense than water, the other is more dense than water, and just pour some water in it, you can actually have the less dense one float and the other one will sink, and you can just scoop off the less dense one and then, pour off and evaporate the water. So it's one way. You can also use something called a centrifuge. So a centrifuge is a device which spins, and the denser material will go down to the bottom. So here's an example of what a centrifuge looks like. Okay, it spins the material, and the denser material basically sinks down to the bottom due to that centrifugal force. Solubility. Okay, maybe one dissolves and one doesn't. All right, so you could take and add some water to it. One will dissolve in the water, makes it a liquid essentially because it's dissolved in that water, and the other one doesn't. And then you can use filtration, like a filter, to actually separate it into, sorry, that's a typo there, into its two separate substances. Okay, and then you can basically like evaporate it off afterwards to get the water away, and you have your two separate substances. You can separate them by boiling point. Okay, so this, again, like I said, once you get that water out of there, you filter it out, you got water now mixed with whatever that soluble substance is. You can then evaporate the water off or boil it off, leaving the other one behind. You can just give it some time. You can actually do this. I've seen people do this where they mix like sugar and flavoring with water, and then they boil the water off, and it forms rock candy. Okay. Now the key with separating by boiling point is the one with the lower boiling point will evaporate or boil off before the other. Okay, so the water here has the lower boiling point than, say, the sugar. All right, and so it boils off, leaving the sugar behind. Now, this is also a solid liquid thing, where one turns into a solid as the other boils off, but you can actually take two liquids and separate them by boiling point as well. Okay, so if you if you separate them, you can actually collect whatever substance was boiled off by using something called a distillation. Right? It looks like this, and here's how it works.
Now, the three major uses of simple distillation are to prepare alcohol, ethanol, to separate the fractions of crude oil, and to separate the gases in air. So how does this work? Nice and simply, when a liquid is heated, eventually it's going to reach its boiling point. At that point, it will turn from a liquid into a gas. It will evaporate. Now, if you have two liquids in your mixture and you only heat it to the lowest boiling point, only one liquid will evaporate. When it evaporates and moves into the condenser, it will then cool down, it will condense, and it will turn back into a liquid. So as long as you don't go above the second liquid's boiling point, as long as you stay below it, you can separate them. The one with the lowest boiling point will end up in the conical flask at the end, and the one with the highest boiling point, which you haven't reached, will stay in your round bottom flask at the start. Let's have a look at it in action then. If we start off with the round bottom flask then, our still. In here I have a mixture of water, which I've dyed blue, and ethanol. Water has a boiling point of 100 degrees and ethanol 78. So what I need to do is heat my mixture up to 78 degrees. As you can see here, as it gets towards 78 degrees, I'm starting to see some of that liquid evaporating. That is my ethanol. As that gas evaporates, it will move into the condenser. Now what the condenser does is it has water all the way around it, so when that gas, that ethanol gas, passes into the condenser, that water will start to cool it down. And as you can see here, my ethanol is condensing, it's turning from a gas back into a liquid. Now because it's a liquid, I need somewhere to collect it. I've used a boiling tube, you can use a conical flask, you can use anything as long as you are collecting that liquid. And as you can see, it is colourless. So you can see I have definitely separated my ethanol, which is colourless, from my dyed water, which is blue.
Similar to boiling point, you can also use freezing point. This is called crystallization. Basically, you cool the mixture down, and then the one with the higher freezing point will freeze before the one with the lower freezing point that basically doesn't freeze to like negative 100 degrees Celsius or whatever. So the one with that higher freezing point will freeze, the other one stays a liquid, and then you can just like filter it out. And this is kind of pretty cool to watch. So here's a little GIF of it where it cools down and then one just kind of solidifies while the other one stays a liquid. Okay. Chromatography is another one. Now this one's kind of weird because it's about how it interacts with another material. So essentially you have it like dissolved and you put it in a solution or something, and that material will then go through that other material. Okay, so your mixture will go through some material, and depending on what it is, they'll go through at different speeds. So one might go through really, really fast, and the other one will go nice and slow. They'll both go through, okay, but because they go at different speeds, they will separate as they go through it. All right, and that's called chromatography.